So we're going to see if we can make some ice or some liquid CO2 by squirting out high pressure carbon dioxide out of this soda stream thing. So while I hold the camera, my sister will press the button. Is that still on the frame? Yep. And I'm going to try to freeze this coupon thing I found. Okay, go. Okay, stop. Did you see that? There's like ice on this. Yeah, let's do it again. Let's see if it's in focus. Closer. Focus. Okay, go. Stop. I don't know if you can see that, but this actually has CO2 liquid on it. Let's try it with stop. Let's try it with something else. How about this log, or kindling, whatever you want to call it. Go. Okay, stop. Look, see the ice on it? Right? Hey, stop melting it.
Want to do it again?
Yeah, let's do it again.
Sorry, I just felt like that.
Okay, stop. And there you go. See, that's frozen CO2 right there. Solid CO2. It is really cold. Okay, let's do it again.
Ready, set, go.
Okay, stop. So, there it is again. So, let's get it focused on this. Wait, okay. So, now we're focused there. Okay, stop. Let's do it on my shoe. Okay. Ooh, yes. Okay, stop.
Oh, it's so cold.
Yeah, there you go. Frozen CO2. We have this thermometer here that is meant for measuring meat temperatures, but I figured it'll work just as well for measuring carbon dioxide temperature. So, for scientific purposes, I'll switch this into Celsius. Celsius, yep, 23 Celsius. And we're going to see how cold the CO2 coming out of this is. So, let's put it right there. Okay, so we have everything set up. This is taped with some handy dandy scotch tape. And let's see, so the room temperature air in here is 22.3 Celsius. I don't know how accurate this thermometer actually is, but let's see how cold we can get this. Okay, there, the temperature is dropping. Okay, 20 Celsius, 19. Let's keep spraying CO2 on it. Ooh, that is cold. 18. Come on. I keep. Oh, it's already cold over here. I think because this is also exposed, it's messing up the temperature. We're at 15 now. 14.6. It's warming up. No. Not even at 0 yet. It's annoying. There we go. 11, 10. So it looks like we need something to push the air back that way. Since I don't want to freeze burn my hands, I'll use my shoe. No, that's not going to work. But got this Wall Street Journal. There we go. Ready, guys? Look at that. -3. Oh, we're going up very fast. Okay, I don't know if you could see that, but it went all the way down to -7, I think. So, I need to find a more efficient way to do this. I'll be back. Okay, I figured since aluminum is a very good insulator, I'd wrap it with aluminum. So, let's go, and now we're back at about room temperature. So let's, I don't even know how much CO2 is left in the canister. Hopefully there's enough to get it down, but this is much more efficient than it was earlier. Let's try to seal all the gaps. I want all the CO2 gas to come out this way. So this is dropping a lot more rapidly.
I think we're low on pressure, so, yeah, sorry guys, I'm gonna have to see if we have another canister somewhere.
Make this work better. Anyway, you know, it'd probably have gotten down to -20 if we had a full canister, but... poop. So, maybe this would work with, like, an air compressor. But this is basically how refrigerators work. So. Anyway, I'm just probably giving myself CO2 poisoning at this point. Anyway, thanks for watching, and I'll make a second part to this video, hopefully. Since it's not exactly getting that cold, I don't think it's frozen CO2, because that would have been really, really cold, like -100 something. What I think this is doing is, since it's pretty humid right now because it rained a couple days ago, I think it's just freezing the water in the air, and then it's spraying it constantly, like this is wet-ish. So it's just condensing water vapor and freezing it. Because, as you could see, we got to -6 Celsius, which is 6 degrees below the freezing point of water. So, guys, sorry, it's not frozen CO2, probably. I mean, it might be. This is really cold, but I think it's frozen water vapor. Anyway, thanks for watching.